Top 30 interview questions and answers for a maintenance planner. A maintenance planner plays a critical role in ensuring the smooth functioning of assets, machinery, and infrastructure within an organization. The role requires strong organizational skills, technical knowledge, communication, and the ability to optimize resources for maximum productivity. Preparing for an interview as a maintenance planner means being ready to discuss planning, scheduling, preventive maintenance, safety standards, and stakeholder management. Below are the top 30 interview questions with structured answers, each designed to help you succeed. 1. Can you explain the role of a maintenance planner? The role of a maintenance planner involves preparing, organizing, and scheduling maintenance tasks to ensure equipment reliability and minimize downtime. A planner develops preventive maintenance plans, allocates resources efficiently, and coordinates with technicians, supervisors, and other departments. The planner also ensures that spare parts and tools are available when needed, while prioritizing safety and compliance. By maintaining accurate records and leveraging CMMS systems, a maintenance planner improves productivity, optimizes costs, and ensures operational continuity across the organization. 2. What are the key responsibilities of a maintenance planner? A maintenance planner's responsibilities include scheduling preventive and corrective maintenance tasks, creating work orders, and ensuring labor and material resources are available. They track equipment performance, update maintenance records, and ensure compliance with safety and regulatory requirements. Coordinating with supervisors, technicians, and procurement teams is crucial for planning successful maintenance activities. Planners also analyze maintenance data to identify improvement opportunities, reduce breakdowns, and extend asset life. Their role bridges the gap between planning strategies and operational execution effectively. 3. How do you prioritize maintenance tasks? Prioritizing maintenance tasks begins with evaluating equipment criticality, safety risks, and operational impact. Tasks directly affecting safety, production continuity, or compliance are given the highest priority. Preventive and predictive tasks come next, followed by minor corrective work. Planners often use a priority matrix to assess urgency versus importance. Effective communication with production teams ensures alignment with operational schedules. Prioritization also involves considering available resources, spare parts, and workforce capacity to balance urgent needs with long-term maintenance planning goals. 4. What is the importance of preventive maintenance? Preventive maintenance is crucial because it reduces unexpected breakdowns, increases asset lifespan, and enhances operational efficiency. By performing scheduled inspections and repairs, organizations can detect early signs of wear, reducing costly emergency repairs. Preventive maintenance improves safety, ensures regulatory compliance, and lowers long-term maintenance costs. It allows production teams to work with minimal interruptions and maximizes equipment availability. Maintenance planners must design effective preventive maintenance schedules to align with organizational goals, balancing operational demands with reliability requirements consistently. 5. How do you develop a maintenance schedule? Developing a maintenance schedule starts with analyzing equipment criticality, manufacturer recommendations, and historical failure data. The planner establishes preventive and predictive maintenance intervals, balancing efficiency and resource availability. Scheduling requires considering technician skills, spare parts inventory, and production timelines. Tools like CMMS help generate work orders, track progress, and optimize schedules. Continuous review of feedback and performance data allows adjustments for improved effectiveness. A strong schedule ensures maximum equipment reliability, reduced downtime, and alignment with organizational production priorities. 6. What software or tools have you used for maintenance planning? Maintenance planners often use computerized maintenance management systems, CMMS, such as SAP PM, Maximo, Oracle, or Infor EAM. These tools help create work orders, manage spare parts inventory, and track maintenance history. They also generate reports for performance analysis and assist with preventive maintenance scheduling. Additionally, tools like Microsoft Excel, MS Project, and asset monitoring systems may complement CMMS use. Familiarity with digital platforms improves planning accuracy, enhances communication, and ensures timely execution of tasks across different maintenance activities. 7. How do you ensure availability of spare parts and materials? Ensuring spare parts availability starts with accurate forecasting based on historical data, critical equipment needs, and preventive maintenance plans. The planner collaborates with procurement and inventory teams to maintain adequate stock levels while avoiding overstocking. A CMMS helps track usage trends, reorder points, and supplier lead times. Effective vendor management and communication are essential for timely deliveries. Planners also establish a critical spares list to minimize downtime risks. This proactive approach ensures efficiency, cost control, and uninterrupted equipment reliability. 8. How do you handle an unexpected equipment breakdown? Handling unexpected breakdowns begins with immediate assessment of the issue's impact on safety and operations. Communication with production and maintenance teams ensures quick mobilization of resources. The planner reprioritizes schedules to accommodate urgent repairs while minimizing disruption to planned tasks. Spare parts and skilled technicians are allocated promptly. Post-repair, root cause analysis is conducted to prevent recurrence. Lessons learned are documented, and preventive actions are added to future schedules. This approach balances quick response with long-term maintenance improvements effectively. 9. Can you explain the difference between corrective, preventive, and predictive maintenance? Corrective maintenance involves repairing equipment after failure occurs. Preventive maintenance focuses on scheduled inspections and servicing to prevent breakdowns. Predictive maintenance, on the other hand, uses data from sensors, monitoring tools, and analysis to forecast potential failures before they happen. While corrective maintenance is reactive, preventive and predictive approaches are proactive. A maintenance planner integrates all three approaches based on equipment criticality, operational needs, and resource availability to achieve maximum reliability and cost-effectiveness across the organization's maintenance strategy. 10. How do you balance maintenance with production requirements? Balancing maintenance with production requires strong communication and coordination between departments. Maintenance schedules are designed around production cycles, minimizing interruptions to operations. Critical tasks are planned during shutdowns or low-demand periods. The planner uses CMMS tools to track and align schedules while ensuring safety and compliance. By involving production managers in the planning process, both maintenance and production goals are achieved. This balance ensures maximum equipment uptime, cost efficiency, and alignment with the organization's operational and business objectives. 11. How do you improve maintenance productivity? Improving maintenance productivity requires planning tasks clearly, ensuring the right materials and tools are available, and scheduling work efficiently. Eliminating delays caused by missing parts or unclear instructions is crucial. Using CMMS systems helps monitor progress and generate performance reports. Training technicians enhances skills and reduces errors. Standardized job plans, clear communication, and effective supervision increase efficiency. Continuous improvement practices, feedback loops, and analysis of downtime data allow planners to refine schedules, optimize resources, and maximize productivity. 12. How do you deal with maintenance backlogs? Managing backlogs begins with categorizing tasks by urgency, safety, and equipment criticality. The planner reviews outstanding work orders and prioritizes essential activities without disrupting ongoing production schedules. Backlogs may be reduced by allocating overtime or scheduling during downtime periods. Data analysis helps identify recurring causes of backlog, such as spare parts shortages or staffing issues. Collaboration with supervisors ensures resources are optimized. Continuous monitoring of backlog levels helps planners balance workload, reduce risks, and improve operational performance sustainably. 13. What is your experience with CMMS systems? My experience with CMMS systems includes creating work orders, scheduling preventive maintenance, and monitoring asset performance. I've used platforms such as SAP PM and Maximo to track parts inventory, assign resources, and generate reports on equipment reliability. CMMS tools have helped streamline planning, minimize downtime, and improve compliance with safety standards. I also leveraged their analytical features to forecast spare part needs and evaluate maintenance trends. These systems have consistently enhanced planning accuracy, transparency, and operational efficiency in organizations. 14. How do you ensure compliance with safety standards? Ensuring safety compliance involves incorporating safety procedures directly into job plans and maintenance schedules. I ensure all work orders include safety guidelines, risk assessments, and required protective equipment. Collaboration with the safety department helps align maintenance tasks with regulations. Regular audits and inspections confirm adherence to standards. I also encourage safety training and toolbox talks for technicians. Any incidents or near misses are documented and analyzed to prevent recurrence. Safety remains an integral part of every planning decision. 15. How do you handle multiple maintenance requests simultaneously? Handling multiple requests requires structured prioritization and resource allocation. I evaluate each request based on urgency, safety risk, and impact on operations. High-priority tasks, such as safety-related or production-critical work, are scheduled first. I use CMMS systems to track requests, assign technicians, and monitor progress. Communication with stakeholders ensures realistic timelines. Delegating tasks according to technician expertise improves efficiency. By balancing workload and maintaining transparency, I ensure all requests are addressed systematically without compromising reliability or quality standards. 16. How do you collaborate with maintenance supervisors and technicians? Collaboration involves regular meetings, clear communication, and sharing detailed job plans. I ensure technicians receive accurate instructions, required materials, and safety information before starting tasks. Feedback from supervisors and technicians is used to refine future planning. I also provide progress updates, coordinate schedules, and resolve conflicts between production and maintenance requirements. Building trust through open communication fosters teamwork and efficiency. Effective collaboration ensures maintenance tasks are executed smoothly, safely, and on time while supporting continuous improvement initiatives. 17. What key metrics do you track in maintenance planning? Key metrics include mean time between failures, MTBF, mean time to repair, MTTR, preventive maintenance compliance, backlog levels, and maintenance cost per unit of output. I also track equipment availability, work order completion rates, and spare parts usage. Monitoring these KPIs provides insights into asset reliability, workforce productivity, and cost efficiency. Regular reporting helps identify trends, recurring issues, and opportunities for improvement. These metrics guide strategic decision-making, improve planning accuracy, and support long-term asset management goals. 18. How do you ensure accurate maintenance documentation? Accurate documentation begins with maintaining up-to-date records in CMMS systems. Each work order includes detailed job descriptions, materials used, technician hours, and safety compliance notes. I encourage technicians to provide feedback after tasks, ensuring records reflect actual conditions. Regular audits of logs and reports help identify inconsistencies. Documenting historical data improves reliability analysis and supports predictive maintenance. By ensuring accuracy and consistency, planners provide valuable information for decision-making, regulatory compliance, and long-term asset performance optimization effectively. 19. How do you plan for plant shutdowns or turnarounds? Shutdown planning begins months in advance with scope definition, task prioritization, and resource allocation. I create detailed schedules covering preventive, corrective, and inspection tasks. Spare parts procurement and vendor coordination are finalized beforehand. I collaborate with cross-functional teams to ensure alignment with production goals. Safety measures are embedded in all activities. During shutdown, progress is tracked closely against the plan. Post-shutdown, performance reviews highlight lessons learned. Effective turnaround planning ensures reliability improvements while minimizing downtime and operational disruptions. 20. How do you reduce maintenance costs without affecting reliability? Cost reduction starts with optimizing preventive maintenance schedules to avoid unnecessary work while preventing failures. Implementing predictive maintenance technologies reduces unplanned downtime. Standardizing job plans and ensuring efficient use of spare parts lowers waste. Negotiating with suppliers for critical parts and using data-driven analysis to forecast needs also improves cost efficiency. Training technicians reduces rework and increases productivity. By balancing proactive maintenance strategies with smart resource management, costs are controlled while equipment reliability and performance are maintained. 21. How do you handle conflicts between production and maintenance schedules? 21. How do you handle conflicts between production and maintenance schedules? Conflicts are addressed through open communication and collaboration with production teams. I first assess the urgency of maintenance work and its impact on safety or equipment reliability. If possible, I align tasks with production downtime or shift changes. In cases where urgent maintenance is required, I present data to justify the decision. Negotiating alternatives and prioritizing shared goals ensures alignment. The objective is to maintain operational continuity while safeguarding equipment, reducing risks, and supporting both maintenance and production efficiency. 22. How do you train or coach technicians on maintenance procedures? Training begins by identifying skill gaps and aligning learning needs with organizational objectives. I organize workshops, toolbox talks, and on-the-job demonstrations to enhance technical knowledge. Standardized job plans and detailed work instructions help technicians follow best practices consistently. I encourage peer-to-peer learning and mentoring for complex tasks. Feedback sessions reinforce strengths and highlight areas for improvement. Training also includes safety awareness and proper tool usage. By developing technician skills, I improve maintenance quality, efficiency, and overall workforce competence. 23. How do you use data analysis in maintenance planning? Data analysis supports proactive decision-making in maintenance planning. I analyze downtime reports, work order history, and spare parts usage to identify recurring failures. Metrics like MTBF and MTTR help measure equipment performance. Predictive analytics from condition monitoring tools forecast potential issues. This information allows optimization of preventive maintenance schedules and resource allocation. Data-driven insights highlight cost-saving opportunities and reliability improvements. By leveraging analytics, I transform raw information into actionable strategies that enhance efficiency, safety, and asset lifecycle management. 24. What is your approach to root cause analysis, RCA? My RCA approach involves gathering detailed information on the failure, interviewing technicians, and reviewing equipment history. I use methods like the 5 whys or fishbone diagram to identify underlying causes. The goal is to distinguish between symptoms and root problems. Corrective actions are then planned and integrated into maintenance schedules. Preventive measures, such as training or design improvements, are documented for future use. This structured RCA approach helps reduce recurrence, improve reliability, and enhance long-term operational efficiency systematically. 25. How do you ensure effective communication across teams? Effective communication involves using clear, consistent channels like daily briefings, emails, and CMMS updates. I ensure technicians, supervisors, and production teams receive accurate schedules and job instructions in advance. Feedback is encouraged and documented for continuous improvement. During critical maintenance activities, real-time updates are shared to track progress. I also foster a culture of openness where concerns are addressed promptly. Strong communication minimizes misunderstandings, builds trust, and ensures seamless coordination across different functions, improving productivity and safety outcomes. 26. How do you handle emergency maintenance situations? Emergency maintenance begins with a rapid assessment of safety risks and operational impact. I immediately coordinate with technicians, supervisors, and production to prioritize urgent repairs. Spare parts and resources are mobilized quickly, and non-critical work is postponed. Communication with stakeholders keeps everyone updated during the process. Once the issue is resolved, I document the event, analyze the root cause, and adjust preventive maintenance plans accordingly. This approach ensures fast recovery while preventing recurrence and maintaining overall reliability standards effectively. 27. How do you measure success as a maintenance planner? Success is measured by equipment reliability, reduced downtime, and effective use of resources. Key indicators include preventive maintenance compliance, backlog reduction, and cost efficiency. Meeting production targets without compromising safety reflects successful planning. Feedback from supervisors and technicians also provides valuable insights into planning effectiveness. Consistently improving KPIs like MTTR and MTBF demonstrates progress. Ultimately, success means aligning maintenance activities with organizational goals, maximizing asset performance, and creating a proactive maintenance culture that supports sustainable operational excellence. 28. How do you deal with vendors and contractors? Dealing with vendors requires building reliable relationships, ensuring timely delivery of spare parts, and negotiating favorable terms. I evaluate vendor performance based on quality, lead time, and cost-effectiveness. During major maintenance activities or shutdowns, I coordinate with contractors to align their work with schedules and safety requirements. Clear contracts and compliance checks are enforced to maintain standards. Regular communication ensures expectations are met. Effective vendor and contractor management guarantees timely execution, reduced downtime, and controlled maintenance costs. 29. How do you ensure continuous improvement in maintenance planning? Continuous improvement involves analyzing performance data, reviewing KPIs, and incorporating feedback from technicians and supervisors. Lessons learned from past maintenance activities guide adjustments in planning. I benchmark processes against industry best practices and adopt new technologies like predictive analytics. Regular training programs enhance workforce efficiency. Collaboration across departments fosters innovation and idea sharing. Continuous improvement means constantly evaluating and refining schedules, processes, and strategies to reduce downtime, improve reliability, and align maintenance activities with evolving organizational objectives effectively. 30. Why should we hire you as a maintenance planner? You should hire me because I bring strong technical knowledge, organizational skills, and proven experience in maintenance planning. I excel in using CMMS systems, analyzing data, and developing schedules that balance reliability with cost efficiency. My ability to collaborate with cross-functional teams ensures seamless execution of maintenance tasks. I focus on safety, compliance, and continuous improvement to enhance asset performance. By combining strategic planning with hands-on problem-solving, I deliver measurable results that align with organizational goals effectively. Conclusion. Preparing for a maintenance planner interview requires demonstrating both technical expertise and strong organizational skills. Employers seek candidates who can reduce downtime, improve reliability, and optimize resources while maintaining safety and compliance. The questions above cover technical knowledge, planning strategies, communication skills, and problem-solving approaches. By practicing these responses, you can present yourself confidently and show how your skills align with the organization's maintenance goals. Ultimately, a successful maintenance planner creates value by ensuring operational continuity and efficiency.